Thank you, Gianluca. Right, so I just clicked the mouse, okay. So thank you very much for having us today here, and thank you for your interest in our presentation. A disclosure slide from my side. Good, so we're gonna do this presentation. I'm going to give you a quick introduction and background as to why we're here today. Edna is going to take you through a pretty detailed deep dive on technical features, and I'm going to close it with our next steps. So in our department, we build global cost-effectiveness models. That means that the models that we build are then taken by our affiliates who adapt them and use them for reimbursement submissions. That means that our models need to cater for a wide range, broad range of stakeholders, and so they need to have quite a number of features and be easy to adapt. Up to now, we have been using Excel. We have templates that we developed internally in the company, and we are using those and adapting them for our global models, and then our affiliates take them. However, we have been using R for stats analysis, and we have been using R for early modeling sometimes. So we thought, why not try to have a model that is in R, a template that we can adapt and use for our affiliates to do their submissions. It's not a small feat, I think, and I don't have to preach to the choir in this room, so I put in some thoughts about why we thought this was a good idea on the slide. Good. So last year, we started our partnership with Howard and his team at Clifton Insights. So we decided to co-develop two core models, a Markov model and a partition survival model. Starting from the base of the Dart framework, but adding a lot of the features we originally had in our Excel templates, and try to cover a little bit more of broader aspects such as societal perspective and different types of sensitivity analysis. We wanted to leverage R's capabilities for validation, unit testing, and automation, but very importantly, we wanted to have what we call a bridge to Excel. So we know that not everybody will be able to switch to R at the same time, and we cover a very broad range of stakeholders. So we thought it would be nice that the global modeler will build a model in R, and then there will be a function that exports it into Excel as a fully functioning standalone model. Without further ado and spoilers, I'll pass it on to Edna for the tech.
Thanks. Yes, so I'll talk you through how it works from a user's perspective, the kind of steps involved. So the user would first choose between a cohort Markov or a partition survival model. They would then define the number and names of states and treatments in their model. This would be limited to 3 for a partition survival model, but for a Markov model, there's no limit to the number of states or treatments that the model can compare. Based on this model specification, we have a function that generates a flexible input sheet. This is an R function, and it's based on the model specification, so it'll generate an input sheet that the user can use with the R code and the Excel model. The user would use that input sheet to add their own specific data from their example, so their raw data, as well as choosing model assumptions, so things like whether to use a survival curve to inform occupancy in the first health state, how treatment duration is specified, drug costs are estimated, etc. So once the user has entered their data, chosen their model assumptions, those can be used to generate a standalone Excel version of the R model. And they then have the option to either run the model in R with automatic report generation or run the model in Excel, or both, depending on the requirements. Looking at the code, this is the code to generate the input sheet. So, like I said, the user specifies number of states, the state names, number of comparators, their names. There's also the option of having multiple drugs within each treatment, if you had combination treatments, for example. The user then specifies where the base input sheet is saved, where they want their own input template to be saved, and they run the function. And that goes through each of the tabs in the input sheet and adds rows, columns, dummy data for any additional treatments or health states that are needed for their example. It also adds all the named ranges that are needed for running the model in R and Excel. And it also writes the formulas that are needed to derive the parameters for cost-effectiveness analysis in Excel. So anything that's beyond just the raw data, so any processing that's done in R, it writes the formulas to do that processing in Excel as well. And just to give you an idea of the scope of the input sheet, there's tabs for general settings, like defining the model options, general inputs like age and time horizon. There's tabs for survival inputs, so extrapolation options for the survival curves, life tables, start and distribution across states. There's options for mortality multiplier. The user, there's tabs there for the user to enter their IPD or Kaplan-Meier data if they want to use that option for informing their survival curves. There's tabs for adverse events, tabs for utilities. So we've got health state utilities, health state dish utilities, care utilities. There's tabs for model structure. So that's where the user would enter their transition probabilities. There's option of using a network meta-analysis to inform the transition probabilities. There's also the option of using a network meta-analysis to inform probabilities of cost and utilities. Then there's multiple tabs for costs, drug costs, health state costs, etc. And there's tabs for the sensitivity analysis. So each of these would be altered by the generate input sheet function to make it exactly the kind of specifications needed for the user's model. So as an example, this is the tab where you'd enter your adverse event probabilities. So the user can change the adverse events that are included. These are treatment specific. They can choose the distribution to use for their probabilities, enter the hyperparameters, so the mean and standard error. The gray columns are the ones that are generated automatically from R, so the user doesn't have to edit these. Those are the kind of formulas that would generate the probabilistic samples needed for the Excel model. There's also the option of, like I said, using a network meta-analysis to inform the probabilities. So yeah, that gives you an idea. This is the model options tab. So this is where the user would specify things like whether to include care utilities, whether to include disutilities related to adverse events, things like that. And then like the transition probabilities tab, the user could enter directly their transition probabilities. And once they open the input sheet, this will be to the exact specifications of their model, so the names and the numbers of states. So once the input sheet is generated and the data is in there, this is the kind of structure of the functions in R. So there's functions to read in the data, define the model based on this data. And then there's functions to generate survival parameters, generate utility and cost parameters. The survival parameters feed into generating the transition matrices and the cohort vectors. And then those, along with the utilities and costs, feed into the functions that generate the total costs and effects. Then the results are analyzed. And alongside this, there's functions for R-Shiny and R-HTA. So the outputs from all this will be results, figures tables in R. You also have a standalone Excel model and a Shiny app. So looking at some of the functions, the first couple are for loading data and defining the model. So once the user has edited the input data, added to the data folder, read it in, we have the class model data and class model def R6 objects that store the model specifications and data inputs, store the key parameters defined in the model. We've used R6 in a deliberately lightweight way, so it's only used here just to maintain transparency. So if users aren't as familiar with object-oriented programming, that this is the only place it's used, just to keep it user-friendly. But these functions allow the user to overwrite the input settings in R. So if they want to interact directly with the R code, they can change the user settings in there. So using the model def probabilistic equals no, for example. Or they can do it in the Excel input sheet and reload that in. Just a note that we've included testing throughout the functions. The last count, there was probably over 100 functions in the package. So for a lot of them, we have input, interim, and output tests. So the tests check that the data going in is right, that the calculations are right, and that the output from the functions is giving you what you want. So this should flag to the user at any point if there's something not right in the data or something going wrong in the code. There's functions for survival analysis. So the survival curves in R fit using FlexCurve Plus. The inputs are provided from the input sheet and loaded in through the model data function. So there's options in there, like I said, for using IPD, Kaplan-Meier curves. The user can just enter the parameter estimates directly, or they can apply hazard ratios. There's also the option to reconstruct IPD from Kaplan-Meier. The user can choose between a variety of distributions, and the functions will output plots and tables for the best fitting models. So there's a lot of flexibility in there. There's then functions for generating results, which take the total costs and total qualities for each treatment and do all the standard cost effectiveness analysis stuff. So yeah, reporting life years from the cohort vectors, given the dominated strategies, the CX cost effectiveness plane. So that's all output in R with some nice plots and tables. There's also sensitivity analysis. So there's a one-way sensitivity analysis which multiplies the parameters by a factor or by 95% confidence intervals. That uses the upper and lower bounds and to plot a tornado plot. And then we also have bivariate deterministic sensitivity analysis in there, which varies two parameters simultaneously, holding the others fixed. There's the R-HTA app. So the run-Shiny function loads the data from the input sheet and creates a graphical user interface. And this allows users to change key settings like the discount rate, the drug costs, utilities, and be able to really quickly see the impact on results in some nice figures and plots as well. And then the R-HTA. So there's the Markov trace R-HTA function, which adds to the input sheet by generating and populating the Markov trace tabs for each treatment. So it uses the Open Excel XX2 package to write the formulas to Excel from R. The exported formulas refer to the data in the input tab, so it means that the R code and the Excel model are using the exact same inputs. The formulas are fully flexible and reactive to the model definition, so they have to work no matter the number of health states or treatments. And once the Markov trace tabs are filled in Excel, the results tables and plots in Excel are also automatically populated. So this is an example of what the formula for writing from R to Excel looks like in R, and then what it looks like in Excel. So the formulas in R are a mixture of text and kind of references to specific columns and rows that have to be calculated in R. So the formulas there are fully flexible to whatever number of health states or conditions, but when they're pasted to Excel, when you open the file in Excel, it just looks the same as a normal Excel formula would. And it refers to all the right places in the other parts of the input sheet. So the advantages of this is that you only need to define the logic once in R. So the logic's there, the code can then automatically generate the correct formulas no matter the number of health states or comparators, transitions. It reduces manual spreadsheet development. So you can imagine if you had 12 different treatments, there'd be a lot of copying and pasting of kind of Markov trace, health state occupancy tabs, and make sure you're referring to the right column and cell. So this reduces the risk of copy and paste errors and saves time. And although it's generated programmatically, the final Excel model just looks like a normal Excel model, so it's transparent, reviewable. As we know, it's a key requirement for a lot of submissions and external validation. And just note that we have tried this with a few examples. The most complicated being this MS model with 31 health states and 13 treatments compared. So we had a previous Excel model from Roche that we used the data inputs and recreated using our own package. So this is a fairly complicated example with transition probabilities driven partly by network meta-analysis results, relapse probabilities affecting cost and utilities informed by a separate network meta-analysis. And nicely, we found that the original model, we were able to closely replicate the results, and our R and R2XL model results exactly matched. So that gives us a bit more confidence that they're both doing the same thing. So yeah, I'll hand back to Caroline.
Thanks, Edna. So to close, I just want to make just 2 points, really. We see this as an iterative process. We know it's very ambitious, so we are at our starting point at the moment, and we know we still have a lot of technical hurdles to resolve and a lot of upskilling to do. So it is an iterative process. Lastly, I am very happy to tell you that we are going to be starting a collaboration with Dawn and the Pentac team in the coming months that is going to look into external validation and stakeholder adoption. So my request to you is that if you are interested to participate on this validation, to please contact Dawn.
Please do.
Yes. Finally, I want to leave you with our vision. So we do want to have this package, these model templates, as an open source package. That would be our way to give back to the community and also make more transparent health economic modeling. So thank you very much for your interest, and thank you, Edna and Howard's team. Questions?
Thank you, brilliant. That's very, very interesting. We do have some time for questions. Are there any from the audience? No, I can maybe start us up. Obviously, it's a great thing that you're thinking of the open source package. Have you considered also some kind of tutorial or write-up in a paper format? Because I think people would equally value that. You know, there's a lot to unpack here, and it might be helpful to have something that guides you through exactly that kind of process.
I hope so. I think we are taking this slowly and we're progressing as we go. But yeah, our initial idea and consideration with Howard's team was also to make a publication to be able to share with everybody. So watch this space, I guess.
Gladly. Any other points from the audience? Yes, 1 and then 2.
Hi. Yeah, great presentation. I'm wondering about sort of like developing the R model for sort of disease areas or treatments that sort of don't fit the model, which would then require some slight adaptation. Have you thought about how AI could be used or sort of like investigated that to adapt the R model when it's necessary to sort of disease areas or interventions which might not fit the template, or sort of appreciate it's maybe in its early stages, so maybe that's something that's not been considered yet. Just wondered if that had been considered at all.
It's not something we've thought about personally, but it's an obvious next step, I suppose, because now that the functionality is in R, it makes it easier to kind of bring in AI. And yeah, we're not sure how exactly it would work, but I think it would be an obvious next step, yeah.
But the model is supposed to be able to work with many disease areas and different strategies. So we're making it comprehensive, and this is our goal.
I think we have another question on the floor, and then perhaps you have some in the chat. I'll just pass it on to you afterwards.
I know you're kind of early days with this, but you kind of have the option to have an Excel. What are your kind of indications of, will you keep this as something where the R is kind of on your side, or are you hoping to submit to agencies and provide the R model?
All right, there you go. Just covering time.
So the answer is yes. If all of the planets align, the agencies would like it. We are prepared internally to support it. Then yes. So the bridge to Excel is essentially fallback option. We would like to proceed with R, but I think that there's many planets that need to align before this is a possibility. But we are exploring it, and we have many affiliates in our network that are interested. So I guess also watch this space.
Lots of watching. I'll pass it on to Howard, who has the questions from the online audience.
Yeah, so first one is from Lydia Walker. The question is, are you typically running the models in R or reverting to Excel once you've built the model? And when you adapt the model, are you doing that in R or Excel?
So we are not, this is not a fully implemented template, so we are still completing the first draft and the first iteration. So I can only answer with what I feel will be the vision for it. So the truth is that both possibilities could be true. So you could have the model in Excel and somebody adapts it in Excel. But our idea is, or the workflow idea that we have is that the global modeler builds in R and exports to Excel. And whoever has the capability / interest, or however that constellation will work, will also use R mainly, but also have Excel for those stakeholders that prefer it.
I think we have time for the last question, but a couple more.
Yeah, one question from Dominic Mustin. Many congratulations to the team. What does the Excel model look like? Do you find it has long, complicated formulas, even when the model is simple? He says amazing, however.
No, not necessarily. We've tried to keep the Excel code as concise as possible as well. So we use things like mmult, and we're using the let functions and things like that. So yeah, I don't think they don't look too different from a normal Excel model. Yeah, hopefully you'll get a chance to see for yourself at some stage.
Okay, maybe last question, and then we'll move to the next talk.
I think that was all of them.
Okay, perfect. Oh, so last question.
I love the integration of unit testing as part of the process. What would you do to extend that if you needed to add an extra QC for a particular adaptation? And have you considered producing automated QC reporting? Because I think that would be really valuable.
Good question, and very good on me that I'm clocking all my steps for today.
Yeah, no, I agree. It'd be great to have a report at the end that told you, okay, everything's matching up. I think another useful addition would be to import in the Excel model again, make sure the Excel results and our results are matching. So that's not something we do programmatically yet. But yeah, definitely it's easy to have this kind of automatic reporting. So why not have it in there? Yeah.
Very much agreed. So thanks very much. Let's give Edna and Carolina a hand because the presentation's been fantastic. Thank you. And I think a great start to today.